functions and relations. So if you look up here on the board, you're going to see an example. This says it's an inverse relation. Okay? So I want you to tell me what you observe. The points are just reversed. Right? So if you look at that, the x and the y is now the y and the x. So 1, 2 goes to 2, 1. 3, 4 goes to 4, 3. 5, 6 goes to 6, 5. Okay? And so that's an example of an inverse relation, and that's what we're going to be talking about. Basically, the x's and the y's are flipped. Okay? So let's go ahead and look at this. It says the vertices of triangle ABC can be represented by the relation. Find the inverse of this relation. So what would the inverse be?
-2, 1.
Okay, so far we handled that right. -2, 1. What else? 5, 2. Very good. And then what comes next?
-1, 4.
-1, 4. So there you go. There's your inverse. Okay, so now it says graph both the relation and the inverse. So I'm going to go ahead and graph the first points. The first point is at 1, -2. The next one is at 2, 5. The next one is at 4, -1. Okay, so this is what the triangle looks like. The next one is going to be at -2, 1. 5, 2. 1, 2, 3, 4, 5, 1, 2. And -1, 4. So I want you to look at those two figures and tell me what you notice. Oops, that one's a little off, but that's okay. Close enough.
They're congruent.
They're congruent. What else?
They intersect each other?
They're similar, except for they're what?
Rotated.
Rotated, kind of shifted around a little bit. Okay? And you're right. So we're going to talk about inverses here. And it says basically if f and f to the -1, that's how we symbolize an inverse. We use a little -1 power. Okay? It doesn't mean -1 power, it means an inverse. But that's what it looks like. If they're inverses, then f of a equals b, if and only if f inverse of b equals a. So basically what they're saying is, in this case down here, my ordered pair is 6, 2. Okay? Here, my ordered pair is 2, 6, since that's an inverse. So it's essentially what we just talked about. They just put it into words here. So let's go ahead and talk a little bit about this next statement. It says when the inverse of a function is a function, the original function is 1 to 1. Recall that the vertical line test can be used to determine whether a relation is a function, and similarly, the horizontal line test can be used to determine whether the inverse of a function is also a function. So basically, if I look at this first f of x, okay, I know it's a function because it passes the horizontal line test, right? If I do, or passes the vertical line test. If I do the horizontal line test, I see that it has an inverse because I can pass a horizontal line and it's only going to touch one point. Let's look at g of x. Is g of x a function? Yes, because it passes the vertical line test. Does it have an inverse?
No.
Not as it is now, because look at this horizontal line. It crosses more than one point. So, basically the horizontal line test tells you whether the function has an inverse. Okay, so now, this next statement says find the inverse of each function, then graph the function and its inverse. We've got some steps we're going to follow. Okay? So, if you want to go ahead and write this down, you're going to do the same steps every time. So, f of x equals 2x minus 5. We're going to find the inverse. First step. Okay? I'm going to replace f of x with y, because those two are the same. Now, if your original function has a y, you can skip this first step. You don't have to worry about it. All right? So that's all we've done first step. Next step. Can somebody see what I did? What did I do?
You change it.
I switched the x and the y around. Okay, so basically, I changed y to x and x to y. I wonder if that has any relation to what I did on the very first slide. Remember how the x's and y's were switched? That's what we're doing now. Now all I'm going to do is solve for y. That means I need to get y all by itself. So on the left side I have x plus 5 equals 2y. I've got one more step to go. What do I need to do? Divide by 2. Good. So my inverse looks like this. But you've got one more step that you need to do. Instead of writing it as y, I'm going to change that y to the proper terminology. There you go. Okay. So all I did is replace y with that f inverse of x, and that'll be the same on every step. So now it wants you to graph. Okay, so let's look at this. What's the y-intercept in that? -5. What's the slope? 2. So here we go. There's my line. Okay? Oops, I missed that point there. So that's what the original line looks like. Now we've got to graph the new one. Okay? That one's kind of tough. But I could write it this way. So what would the y-intercept be? 5/2, which is actually 2.5. What is the slope going to be? 1/2. So up 1 over 2. Up 1 over 2. And so here we go. This is what it's going to look like. What do you think so far? Not too bad? Let's look at another one. So first step is to do what?
Change f of x to y.
Change the f of x to y. Very first step. Okay? What do I do now?
Switch to the x and y.
Switch the x and y. So really it becomes x equals y squared plus 1.
And solve for that.
Yep. So tell me.
X
Minus what? What do I do now? Square root. Square root of x minus 1 equals y, which really means f inverse of y, or f inverse of x. So let's go ahead and graph x squared plus 1. Do we remember what x squared plus 1 is going to be? What does x squared look like? A u. Perfect. Okay. So now we need to figure out where is the tip of the u. So the best way to figure that out is let's let x equal 0. So if I let x equal 0, what do I get? 1. If I let x equal 1, what do I get? 2, because that's 1 squared plus 1. So here's what your graph is going to look like. What's wrong with that graph? It doesn't pass the horizontal line test. So technically, this function does not have an inverse. Okay, so there you go. Now I know some of you are like, why did we even go through all the steps of finding the inverse? It was more practice, and I actually wanted you to practice finding that inverse. Okay, so that's why. But no inverse because it fails the horizontal line test at numerous places.
So only if it passes both tests?
Yes.
then
Okay. Alrighty. So, real quick, what we're going to do is we're going to show now that two functions are inverses, and this deals with some of the stuff we did yesterday. Okay, and basically two functions, f and g, are inverse functions if and only if both of their compositions are the identity function. So basically, here's our steps that we're going to do. To show their inverses, we're going to show that f of g of x equals x, and we're going to show that g of f of x equals x. So that f of g of x and g of f of x, that's what we learned how to do yesterday. So we're going to look at two examples, and we'll be done for today. So let's start with that one. Determine whether each pair is in our inverse functions. So basically, I want to show that f of g of x equals x. So from yesterday, what is the very first thing that I do? Yep. Take g of x here, and I'm going to plug in this case, 1/3 x minus 3. All I'm going to do is replace that. Now this says I go to what function? The f. So I'm going to take this, I'm going to go to the f function, and where I see x, I'm going to put that in. Okay. So I've got 3 times 1/3 x minus 3, and then plus 9. So what do you do with the 3? Distribute. What's 3 times 1/3? 1, so I have 1x. What's 3 times negative 3? What do you get? So you've shown one of the ways. Now we got to show the other way. If you don't get x, you've done something wrong. And these are kind of like essay questions. That means I look at your steps. So let's do the next one. G of f of x. Very first thing, put f of x in place. So I've got g of 3x plus 9. So what function do I go to? G function. So I'm going to take this, plug it in right here. So I've got 1/3 times 3x plus 9 minus 3. So what do you need to do? Distribute. And what do you get? 1x plus 3 minus 3, and that gives me, and there you go. You've shown their inverses. That's all you need to do. Questions on that? Oh, let's go back. All right, we're going to look at this one because this one's a little different with the squared. Same process, but we're going to go ahead and look at this one. So first of all, f of x equals 4x squared, g of x equals 2 root x. So very first step, f of g of x. So now I'm going to go ahead and substitute in g of x, which is what?
2 root x.
So I've really got f 2 root x. Okay? So f of 2 root x. And so if I go ahead and plug in 2 root x, I'm going to go ahead and plug this in right up here. So really I have 4 times 2 root x squared. So let's go ahead and distribute that. So really this is 4 times what? 4x. What does that give me? Are those inverses? Nope. So these are not inverses.
And the inverse has to come out to 0, or
Actually,
Has to come out to 1x.
So does that mean g of f of x won't be an inverse?
Right.
So if it would have been negative 2 root x, it would have been inverse.
Yes. You mean negative root 2x?
Yeah.
Yes. Well, no. Negative root 2x still won't work. So, okay? So this is what you need to do on page 396. You need to do 10 through 38, the evens. Okay, page 396, 10 through 38, the evens.